In this episode, we turn to the part of recovery planning that separates confidence from assumption. A disaster recovery plan, DRP, may look solid when it is neatly written, formally approved, and stored where the right people can find it. But none of that proves it will actually work when systems fail and pressure rises. The only way an organization learns whether recovery arrangements are realistic is by testing the plan, evaluating the results honestly, and maintaining the plan as the environment changes over time. For a beginner, this topic is important because it shows that recovery planning is not finished when the document is created. It becomes meaningful only when the organization puts the plan under stress, studies what happened, corrects weaknesses, and keeps the recovery approach aligned with the systems and business needs it is supposed to protect. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful place to start is by remembering what the DRP is meant to do. It is the organized approach for restoring systems, infrastructure, applications, and data after serious disruption so that the organization can return to an acceptable level of operation. That means the plan is not only a technical reference. It is a promise that critical recovery actions have been thought through in advance, that responsibilities are understood, and that the organization has a practical path for restoring what matters most. Testing matters because those promises can easily be overstated when they have never been challenged. A plan may say that systems can be restored quickly, that backups are dependable, that alternate processing will work, or that teams know their roles. But until the organization runs exercises and observes real performance, those claims remain largely theoretical. Testing turns recovery planning into evidence, and evaluation turns that evidence into useful learning. Beginners sometimes assume that testing is only necessary for highly regulated organizations or for companies facing constant cyber threats, but that is much too narrow. Any organization that depends on information systems can suffer disruption from hardware failure, software error, power problems, human mistakes, vendor issues, natural events, or malicious activity. The more the business depends on technology for daily operations, customer service, financial processing, or communications, the more important it becomes to validate recovery plans before a real incident occurs. Without testing, teams often discover problems too late, such as incorrect contact information, missing dependencies, broken recovery sequences, outdated instructions, or unrealistic expectations about how quickly systems can be restored. A plan that has never been tested may still be better than having no plan at all, but it should not create false confidence. The point of testing is not to create embarrassment. The point is to find gaps early, while the organization still has time to improve. One reason testing is so important is that disaster recovery is deeply tied to business priorities, not just technical activity. Recovery time objective, RTO, and recovery point objective, RPO, help define how quickly systems need to come back and how much data loss is acceptable, but those targets only matter if the organization can actually meet them in practice. Business impact analysis, BIA, may identify which services are most critical, yet the DERP still needs to prove that the supporting technology can be restored in the right order and within acceptable time frames. A plan that looks reasonable on paper may fail when teams try to recover interconnected systems under realistic conditions. For example, an application may technically start up, but it may still be unusable because its database was not restored properly, identity services are unavailable, or network dependencies were overlooked. Testing gives the organization a chance to see whether recovery priorities and technical realities actually line up with one another. Not every test has to be large, expensive, or disruptive, and that is a helpful thing for beginners to understand. Organizations often use a range of testing methods, each designed to reveal different kinds of weaknesses. Some tests are review-based and focus on walking through the plan step by step to confirm roles, contact details, dependencies, and activation criteria. Others are scenario-based exercises where participants talk through how they would respond to a realistic disruption, which helps expose confusion in decision-making and communication. More advanced activities may include simulations, partial technical recoveries, backup restoration exercises, failover activities, or coordinated events involving business teams, infrastructure teams, and external providers. The value of this range is that each method can uncover useful information without requiring the organization to jump immediately into a full-scale operational test. Mature recovery programs usually build testing in stages, so learning happens progressively rather than all at once. A walkthrough is one of the simplest and most useful places to begin because it can reveal obvious problems before deeper testing starts. During a walkthrough, the people responsible for the DRP review the plan together, confirm that it reflects the current environment, and discuss how it would be used in a specific disruption scenario. This may sound basic, but even simple reviews often uncover serious issues, such as obsolete system names, roles assigned to people who have left the company, missing vendor contacts, incorrect recovery sequences, or assumptions that no longer match the actual infrastructure. A walkthrough also helps teams see whether the language in the plan is clear enough to support action under pressure. If experienced staff members cannot quickly explain what the plan expects them to do, the document may be too vague, too dense, or too outdated to be reliable during a real event. In that sense, even low-intensity testing provides valuable evidence about whether the plan is truly usable. Scenario-based exercises add more realism by asking participants to respond to a developing event instead of merely reviewing the document. In this kind of test, a team may be told that a major application is unavailable, that a data center has lost power, that ransomware has affected core systems, or that a regional outage is preventing normal access to infrastructure. Participants then work through what decisions must be made, who should be notified, which systems take priority, what recovery path should begin, and how progress would be tracked. These exercises are powerful because they show how people think under time pressure and uncertainty. A plan may look clean and organized when read quietly, but a scenario reveals whether recovery teams understand authority, escalation, communication paths, and business priorities when events are moving quickly. It also highlights whether the DRP connects effectively with related activities such as incident response, crisis communications, and broader continuity efforts. Technical recovery testing takes the learning even further because it asks the organization to verify whether restoration activities can actually be performed. This may include restoring backup data, rebuilding servers, recovering virtual systems, reconnecting databases, validating configurations, or moving processing to alternate environments. Technical testing is especially valuable because it often reveals problems that discussion alone cannot uncover. A backup job may appear successful in a report, yet the restore may fail because the data is incomplete, credentials are outdated, software versions are incompatible, or supporting systems are missing. A failover process may seem dependable in design, but during testing the organization may find that performance is inadequate, dependencies were underestimated, or the recovery sequence does not produce usable service in the expected timeframe. For a beginner, this is an important lesson. Recovery is not proven by status messages or written promises. It is proven when usable systems and trustworthy data can be brought back under controlled conditions. Testing also helps expose the difference between recovering components and recovering services. A server can be restored, a database can be loaded, and a network path can be reestablished, yet the business may still be unable to function if the restored environment does not support meaningful operations. This is why good DRP testing should focus not only on whether technical tasks were completed, but also on whether critical services were truly returned to a usable state. A payroll platform, customer portal, or transaction system is not recovered simply because part of its infrastructure is online. It is recovered when the organization can verify that required functions, data integrity, access controls, and dependent services are working together in a way that supports business use. That service perspective matters because it keeps the organization from mistaking technical activity for operational recovery. It also aligns testing more closely with the real reason the DRP exists in the first place, which is to restore business supporting capability. After testing takes place, evaluation becomes the discipline that turns an exercise into improvement. Evaluation means looking carefully at what happened, what succeeded, what failed, what was unclear, and what risks remain based on the results. This is not a matter of assigning blame. It is a matter of identifying reality as accurately as possible so corrective action can be based on facts instead of optimism. A good evaluation examines technical performance, role clarity, communication quality, timing, dependency handling, data restoration success, vendor coordination, and alignment with required recovery priorities. It also asks whether the test reflected meaningful business conditions or whether it was too narrow or too easy to reveal deeper weaknesses. When evaluation is done honestly, it becomes one of the most valuable parts of the recovery program because it shows leaders and auditors where the plan is credible, where it needs refinement, and where risks remain more serious than the organization may have assumed. Documentation of test results is essential because without it, the organization cannot prove what was learned or whether problems were actually addressed. Useful documentation should record the scope of the test, the scenario used, the participants involved, the systems or services tested, the expected outcomes, the actual outcomes, and the issues that were identified during the exercise. It should also capture observations about timing, coordination, technical performance, and any gaps between expected recovery capability and what the organization actually demonstrated. This matters for several reasons. First, it provides accountability by showing that testing occurred in a structured and repeatable way. Second, it creates a history of improvement or stagnation over time, which helps leaders judge whether the DRP is maturing. Third, it gives auditors and management concrete evidence that recovery capability is being evaluated through real activity rather than assumed to exist without verification. Once weaknesses have been identified, maintenance becomes the ongoing work of keeping the DRP accurate, relevant, and aligned with the environment it is supposed to protect. This is where many organizations struggle because they may create a plan, run an exercise, record a list of issues, and then allow the document to age while the business and technology landscape continue changing around it. New applications are introduced, servers are retired, vendors change, remote work patterns evolve, data locations shift, and business priorities are updated. If the DERP does not change with them, then the plan gradually stops representing reality. Maintenance includes updating roles, contact information, dependencies, recovery procedures, architecture details, backup assumptions, and priorities based on current business impact. It also includes tracking corrective actions from testing so that identified gaps do not remain open indefinitely. In practical terms, maintenance is what keeps the DERP alive rather than allowing it to become a historical artifact that no longer supports real recovery. Change in the environment is one of the strongest reasons why maintenance can never be treated as a one-time cleanup task. Technology environments are dynamic, and even organizations with stable operations still experience enough gradual change to weaken an unmaintained recovery plan. Cloud migrations, software updates, reorganizations, acquisitions, staffing turnover, facility changes, and modified vendor relationships can all affect how disaster recovery must actually occur. A DERP that was accurate a year ago may now reference the wrong architecture, overlook a new critical application, or depend on people who are no longer in the right roles. This is why strong organizations connect DRP maintenance to broader governance processes such as change management, risk review, and periodic control assessment. When important changes occur, recovery planning should be reviewed as part of the change, not rediscovered later during a crisis. That connection helps prevent the plan from drifting away from the environment it is meant to support. There are also several misconceptions that can weaken testing, evaluation, and maintenance if they are not corrected. One common mistake is thinking that a single successful test proves the organization is fully prepared for any future disruption. In reality, each test examines only part of the environment, under selected conditions, and at a specific point in time. Another mistake is treating testing as a compliance exercise whose main purpose is to satisfy auditors, rather than as a practical opportunity to improve recovery capability. Some organizations also avoid difficult scenarios because they do not want the discomfort of exposing weaknesses, but that choice protects appearances more than resilience. Another misconception is that if backups exist, the DRP is basically covered. Backups matter, but recovery also depends on sequencing, dependencies, people, communications, validation, and the ability to restore usable services under pressure. Serious recovery planning requires all of those elements to be examined together. From an audit perspective, this topic is especially rich because testing, evaluation, and maintenance provide some of the strongest evidence of whether disaster recovery controls are genuine. An auditor will usually want to know whether the organization has a defined testing program, whether the tests are relevant to critical systems and services, whether results are documented, whether issues are tracked to closure, and whether the DRP is updated as the environment changes. The mere existence of a plan is rarely persuasive on its own. What matters is whether the organization behaves as if recovery readiness is an operational responsibility rather than a paperwork exercise. Evidence such as test schedules, scenarios, results summaries, corrective action logs, updated plan versions, and management review records can all help show whether the recovery program is active and improving. For the learner, that perspective reinforces an important principle of assurance work. Controls are most trustworthy when they are exercised, measured, reviewed, and maintained over time. The core lesson should be clear. Testing shows whether the DRP can work under realistic conditions. Evaluation shows what the organization learned from those tests. And maintenance keeps the recovery approach aligned with a changing business and technology environment. None of those activities can be skipped without weakening the overall recovery capability, because a plan that is never tested remains unproven, a test that is never evaluated produces little value, and a plan that is never maintained slowly loses its connection to reality. For someone studying CISA, this topic matters because it brings together governance, technical recovery, operational discipline, and assurance in one practical area of control. It demonstrates that disaster recovery is not a document to admire from a distance. It is a living capability that must be challenged, studied, updated, and improved so the organization can recover with confidence when serious disruption becomes real.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.